Hello and welcome to day 6. We are in the final stretch for Unit 3. Today we're going to be looking at negative exponents. Negative exponents, what this says is that if you have a base raised to a negative exponent, so in this case a is raised to negative n, the entire base that's raised to negative n will move. If it was in the numerator, it'll move to the denominator, or if it was in the denominator, it would move to the numerator, and the exponent becomes positive. So in this case, a to the negative n over 1, we move a to the negative n to the denominator, and you're going to get 1 over a to the n. Well, why is it 1 on top? Because there's really always a 1 out in front. That 1 is not being raised to the negative exponent. That 1 is out in front, it's only the a. So we also know that 1 over a to the negative n, if I have that, I move it, if I have a negative exponent here, I move it to the numerator, and that would equal just a to the n. The exponent does become positive after it is moved. So let's look here. Numbers 1 and 2 at the bottom, and then we'll go to page 24. C to the negative 4, what I like to do is circle if you have a negative exponent. And then I draw arrows to where it should go. So c to the negative 4 is in the numerator, it moves to the denominator, so I write c to the positive 4. And d to the negative second was in the denominator, it moves to the numerator, d to the second. We also have to remember our rules of exponents. And our rules of exponents state that if they're being multiplied, remember that you add. So a to the b times a to the c equals a to the b plus c. We talked about that before. So let's look here. I have a to the negative 5 and b to the negative 3. Notice I did not circle the a. The a really has a positive 1 exponent. So I'm going to move that down, move that up. I keep the a. I write that first. I do not want to forget that a, so I write what I did not move first. Then I move a to the cube down and b to the negative 3 up. Now what I have is b cubed in the numerator. I have a to the first and a to the third. I have 1a and 3a's. I now have a to the fourth, and that is my answer. So let's try 3 and 4, and then I'll have you attempt 5, 6, and 7. So let's try this again. X to the negative 2, I circle, move to the bottom. Y to the negative 3, move to the bottom. Y to the negative 1, man, I move that up. And x to the negative 5, I move that up. That gets a little ugly. If you can't see it all, I understand. Let's erase it. But I'm just going to rewrite this because that got really bad. X to the negative second moves to the bottom. Y to the negative 3 moves to the bottom. X to the negative 5 moves to the top. And y to the negative 1 moves to the top. Now, x to the 5th divided by x squared. We talked about this. If I have 5 x's in the numerator divided by 2 x's in the denominator, those 2 are gone. So you're left with x cubed. And if I have y, 1 y on the top and 3 y's on the bottom, I'm left with 2 y's in the denominator. So 5 minus 2 gives you 3. That's how it's a quick way to do that. And 3 minus 1 gives you 2, but there's more in the denominator, so it stays in the denominator. Let's try 4 here. An exponent to an exponent, you multiply when you have an exponent to an exponent. So we're going to have r to the negative 4 times 1/2 over r to the negative 6 times 1/2. So I'm going to get r to the negative second, if you do that math out, over r to the negative 3. I flip-flop those, r cubed over r squared, and then 3 minus 2 gives you r to the first. Now another way of doing this could have been to flip the insides first. So r to the 6 would go to the numerator, r to the fourth, goes to the denominator, all raised to the 1/2. And then you could have done this out. So either way will work. So can you please attempt 5, 6, and 7? And so hopefully you got his answers for 5, 6, and 7. Please pause, and if you need to look at that. We're going to go right on to numbers 8 and 9 for right now. What the common mistake for etas here, notice that this is all squared. It's 3p to the negative 5r squared times 3p to the negative 5r squared. Now if you don't want to write that out, I understand, but what you cannot forget to do, is square the 3. So what we need to do is square the 3. 3 times 3 is 9, it's not 6. When you have an exponent to an exponent, you multiply, so p to the negative 10 and r to the 4th. All divided by 2, p to the negative 1, r to the negative 4. Now you move what has negative exponents. And you move them. The 9 over 2 does not move. Now I have p to the negative 10, so I know I'm p to the 10 will go in the denominator. P to the 1st comes up top. Oops. R to the 4th times r to the 4th. And I can rewrite that as 9 over 2. I have 10 p's in the denominator, 1 p in the numerator, therefore I'm left with 9 p's in the denominator, and 4 and 4 gives us 8. So I get 9 halves, r to the 8th, p to the 9th. You guys try 9. We'll check that in class. We're going to go right to 10. For number 10, there's two ways to look at this. One, we have a negative 2. I could move that right to the denominator right away. So 6x squared y to the negative 4 all squared, x cubed y to the negative 1. Or we could distribute first, okay, that negative 2 to each term. So I'm going to get 6 to the negative 2nd, x to the negative 4th, y to the negative 8th, all divided by x cubed y to the negative 1. Either way will give us the same answer. 6 to the negative 2nd brings down the 6 squared, so I'm going to be left with 36 in the denominator. I like this way better, just easier for me to see, because I'm going to write 6x to the 4th and an x cubed here, give us x to the 7th, and y to the negative 8th and y to the negative 1. So that should be a positive 8. I hope one of you caught me on that. So that should be a positive 8, negative 4 times negative 2. And again, nice way that I showed this twice, because y to the negative 8 and y to the negative 1 will give us y to the 9th. So we should add y to the 9th over 36x to the 7th. And you guys are going to do number 9 on your own. The next idea that we're going to look at, so that was understanding fractions with negative exponents. The next thing that we're going to look at is solving. And we're going to look at the easier version here, and then we'll get into the more difficult version in class. So what if I state 5 to the 3rd equals 5 to the x? If I have 5 to the 3rd equals 5 to the x, what does x need to be? And almost all of you right away would say, well, x has to equal 3 because 5 cubed equals 5 cubed. That's the idea that we're going to use here. If we have the same bases, the exponents need to be the same. It's kind of common sense there. X bases are the same, the exponents need to be the same for them to be equal. And so in this case, notice that we have the same bases. Therefore, I can set, notice that there's only one base of 3, I can set the exponents, equal to each other because the bases are the same. And then I'm going to solve. Subtract x, subtract 5, x to equal negative 1. And you can test that in your calculator. You can put this into y1, this into y2, and make sure that you have the same y values when x equals negative 1. But of course, we're going to get a little more difficult. Let's go to number 2. Notice that I have two bases here. When I have two bases, I need to make it so there's only one base, just like there was in number 1. I have to use the properties of exponents. When I have the same base, 2 to the 3x multiplied by 2 to the 7, that equals 2 to the 3x plus 7. So I can rewrite that as 2 to the 3x plus 7 using the properties of exponents. When you multiply, you add the exponents. And now look, I only have one base of 2 on each side. Therefore, I can now set the exponents together, subtract the 3x, subtract the 6, and get x to equal 1. And again, you can test it if you want to in the calculator. Let's look at number 3. In number 3, we have an exponent in the denominator. We need to move it to the numerator. So I'm going to rewrite this as 4x to the 6 to the 2 minus 2x equals 4. If I move it to the numerator from the denominator, I have to negate the exponent. And now I have one base of 4 on each side. Therefore, I set the exponents together, and I will get 6 to equal negative 3x, and so x to equal negative 2. In the last one for today's video, we'll look at this one, and again, we look at it, we say, oh my goodness, there's 3 bases of 3 on one side and 2 bases of 3 on the next side. What am I going to do? Well, we use the properties. I'm going to add the exponents together. 2 minus x plus 8 equals 3 to the 4x plus 2. You add the exponents together. Notice that negative x and x will be gone, so I'm going to be left with 3 to this negative 6 equals 3 to the 4x plus 2. I can then set the exponents equal. And let's see here, subtract the 2. I'm going to get 4x to equal negative 8, so x equals negative 2. And again, you can always go back and check using the calculator. In class, we will look at the rest of numbers 5 through 12. And with that, enjoy the day. If you have any questions, please write them down, and I'll see you in class.